that's what we did. Okay, we created a graph. It had 15 random edges and 20 nodes. Okay, so now we also we assign different colors to the nodes. Colors are attributes. You can give any element of these plots different kinds of attributes. For example, the size, the names, the width in the case of edges, whether they're solid, whether they are dashed, whether they are colored, as well as the layout of the plot as a whole. You can assign different attributes in the form of named layouts. So let's take a look at this next example. You can load graphs. We're creating graphs from scratch, but you can also load them in using the function readGraph, which is part of the iGraph package. And note that we're actually reading it off of a internet site. Not quite sure where this is. HU, this karate.net. Here's a question: what are some classic example models that could utilize graph? We'll come to that in a second. We'll look at a couple of the classic models. This is very useful for any sort of linear modeling, visualization of linear modeling for sure. Okay, so we read this and we plot it. This is a, if I'm pronouncing it correctly, a Paget graph. And I did look up some documentation for, I see your comment, for Paget, and placed it in your folder. One of the basic attributes of Paget graphs is they are meant for very, very large graphs. It's if you're dealing with atomic structures, and there are certain types of networks that occur in nature that are huge, and Paget graphs have characteristics that enable you to model them quickly. Here's another comment: how does it decide how many of those should be directed and undirected? They're all either directed or undirected, and it's an argument. The default is undirected, I believe. No, that's not right. Well, here, let's take a look. All we have to do is, the default, I believe, is directed. So let's look. I'm not sure. Here's the main function, and yes, empty is yes. Directed is the default. Okay, so you can, I don't know if you can see this, the print's a little small, but so unless you say directed is false, this graph we read in was already created. So whatever it was, whatever the attribute was, whatever this argument value was, determined why we didn't have directions. Okay. So we also have graph generators. Here are some of the classic types of graphs, and I wasn't familiar with these until last week. Edos Renyi, if I'm saying this correctly, Barabasi Albert, and the Watts Strogats. So let's generate some of these. Try and get this window big enough. Take a look at the script before we do it. Let's see, Joe, get back to your comment. What are some of the classic example models that could utilize iGraph? I think I misread your question at first. Well, anything, just about anything. You know that my background is path modeling. This is a perfect application for that, for showing the results. Anything, we're going to use this for the purpose of visualizing social networks. Okay, because it allows you to visually arrange the connections of clusters, if you will, groups that are associated with each other. We'll be looking at tweets. We'll be looking at the frequency of words in tweets and the frequency of words in documents. So it's really an extension of, you can view it as an extension of association analysis, clustering, if you will, where you're just trying to understand visually how things are connected to each other. PCA would be one approach, but it doesn't have to be a PCA. And this package has, it's different. I mean, it has so many functions that enable you to control the look and feel and the attributes of the elements themselves. I don't think you have that in just principal components that I'm aware of in R. So let's continue. So anyway, let me draw these and then we'll come back and take a look. So that's our ER graph. We've been looking at that. It is undirected. This is the third one. And it's, you notice these are directed. Actually, they are directed. You can't see them. The arrowheads are behind them. Okay, so it's the distinction is in the layout more than anything. Okay. Okay, so let's look at how you dress these up, how you change the attributes. And so we'll start with this, with the ER, and we'll do this step at a time so we can see exactly what each command is accomplishing. And so here's our basic ER plot. And there are 10 vertices, and I'm not sure exactly what this argument, we could look it up, but we'll probably figure it out in a second. Probably the weights of the edges, I would guess. Let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4. The degrees of all of these are different. I'm not sure, but let's continue. As this example is meant to show you how to assign colors. So here we're going to randomly choose the color red or black, and we will assign it to the nodes. Okay, so we'll end up with a very similar plot, but the nodes will be colored. And if we zoom this, the edges actually are a black color, but we are going to assign them all the color of gray. Note that you can assign values to the attributes like this. Okay, so we're going to make the edges gray, and you can barely see the change actually. It's just kind of, they're lighter a little bit. And then we will assign red vertices to the variable red, and this doesn't change the plot at all because all we did was assign values to this variable red, and so if we plot it, we don't see any difference. And then we will make the edges red that are connected to the red nodes. So, first of all, let's get black. We're going to assign the color black to BL And again, that makes no change at all. And then we're going to make the edges or the links that are associated with the red nodes red, and for the black nodes black, and the remaining edges will be gray. Now, note that it's not until I zoom it here the black, here's a red one, this is a red one. It's such a fine shade you can hardly see it. And then these two are red. These are gray. This one is gray.